So, what is science anyway? Having a strong understanding of science will help us interpret all of evolutionary theory. Science! It's pretty cool. We have a couple goals for this lecture. We're going to start off talking about what science is. Then we'll talk about some of the different types of science. We'll talk about how to make a hypothesis and what they are. And lastly, we'll go over a couple steps on how to read a scientific paper. But let's start off. What is science anyway? Science is a process. It is a process by which we are trying to understand the natural world, and we're trying to get reliable information about different things that happen. Why is the sky blue? Why don't we just float? All of these answers or questions we try to answer. In science, it's really about we first observe what is out there. Then we try and generalize because we might notice several similar things that appear to be connected. And then we try and verify those generalizations. The things we use are something called empirical evidence. And this is just a fancy word that means experimental. This means we observe and then experiment on data about the world. One of the important things about this data, though, is it must be observable by more than one person. There are many wonderful things in the world, but not all of them count as scientific evidence. So some things that aren't scientific evidence, hearsay. That thing you heard from your friend of a friend, or that one experience you remember reading about on Tumblr, that may or may not be true. It really depends on what you're talking about. If you heard something that sounds interesting, cool. Go look it up and verify it. Revelatory evidence, something that's revealed by a deity, that is not scientific because another person can't experience that. It may be magical, personally transformative, just not scientific. And lastly, your emotions. They are super important. You should listen to them and work on them. But they are something only you can experience, so they also don't constitute scientific evidence. One of the things we try to do in science is be rational or have logical reasoning. Unfortunately, we're pretty bad at it. There are a couple of logical fallacies that are a little too easy for us to fall into. One of the most common is the ad hominem fallacy. So here, instead of attacking the theory itself or the matter at hand, you go straight for the person and being like, you're a bad person, so obviously your theory is wrong. We're seeing that a lot today, especially when issues of race and racism come up, and saying that someone's opinion isn't valid because they are uneducated or simply because you may not agree with their point of view. So the snowflake comment also falls under the ad hominem fallacy. Another one you may run across is called the straw man. So here you are oversimplifying an argument, grossly oversimplifying it to the point that it is misrepresented. So that makes it easier to attack and easier to tear down. So one thing you might have heard recently is distorting the Black Lives Matter movement by saying that all its supporters hate white people. That's not what it's about. If you think that, I suggest you go look that up. Our next fallacy is the red herring fallacy. So here, you're just taking a left turn and be like, oh, let's talk about this other thing because the thing that you brought up, that's actually hard to deal with. So I'm just going to distract you. So here, you're just distracting from the issue. Unfortunately, we're seeing this a lot right now where people are bringing up other unrelated incidents of civilians killing police or Black people killing white people to divert from racism and police brutality. Murder sucks. But just because another person died in a different situation doesn't invalidate the experiences of Black people. Our next one is anecdotal evidence. So using a personal example to undermine an entire argument. Your personal experience is valid for some situations, and it is also valid for you. But just because you may have had a particular experience doesn't mean that that is the norm for the rest of people out there. And everyone should take time to listen to other people because you can only learn about other people's experiences by listening. So make sure you aren't dismissing police brutality just because you personally haven't experienced it. Our next one is our false dilemma. So now you're making an argument, two sides of an argument seem diametrically opposed, so you can only choose one or the other. This is a form of oversimplification. We're seeing this right now by some people saying you can either be for or against the police, when in reality you can still respect them but want to uphold them to high standards. I also see this a lot when people try to pit religion and science against each other, especially evolutionary biology. Science tells us what the world is, how it works. Science can be pretty poorly misused, and that's happened over and over and over again. Religion tells us how to interact with people, and both of those are really important, and they shouldn't be opposed with each other. So remember to listen, whether you're talking about larger social issues today or if you're just trying to better understand science. Just because you don't agree with something someone says doesn't mean it's true or false. So always make sure to listen and then go and back it up yourself. I did not create these lovely graphics. That was the work of graphic designer Noelle Kress. I highly recommend you check out the rest of her work on her website. Another thing we want to think about with science is we do want to be a little bit of a skeptic. We do want to question the things around us, like question the assumptions people have, questions the evidence they bring, questions the explanations they use. There is, a line. Don't be a jerk about it, but also don't blindly accept everything. So if someone does tell you something, ask them why, but ask them genuinely so you can better understand what's going on. Another thing we want to avoid in science is bias. A common type of bias you see in the world is confirmation bias. So this is when people actively seek out evidence that support what they believe, and then they avoid everything that doesn't quite match. Unfortunately, this specific type of bias has been on the rise over the past couple of years. We also occasionally see something called self-serving bias, where people attribute successes to their personal efforts and failures to external sources. So we just talked a little bit about what science is and some of the things that make it difficult to participate in science. So can you explain? What does science try to do?